Hello everyone, welcome to this discussion where we're looking at the Cramers Rule. Okay, so Cramers Rule is simply a method that is used under matrices, particularly to solve system of linear equations. So in a case where we are given a system of linear equations with unknown variables, you can simply use this method as long as the determinant is not equal to 0. So I'm going to explain where the determinant comes in. So the Cramers Rule is used to simply solve system of linear equations, that is with regards to the study of matrices. So what we have is that here we'll have the Cramers Rule to be expressed in a form where we have something like this equal to B. Now if you look at this, A simply stands for a matrix of coefficients. So A represents a matrix of coefficients, right? So these are simply numbers that we're talking about. Then the X here is simply a matrix of variables, and this is always a column matrix. This is a matrix of variables, where we have that we only have a matrix which has a single column, and in this particular matrix the elements are simply the variables that we are solving for, okay, depending on how many variables are in that particular system of linear equations. Then coming to B is simply a matrix of constants. This is also a column matrix. With this one, as you can see from this expression, we have B is on the right hand side, so I mean that this is simply a matrix that gives us the values that we have on the right hand side that we get upon solving the system of equations that we get to have on the left hand side. Right, so this is what we have. Now we're going to simply use the Cramers Rule in the case where we have something like this, okay, where A is simply a matrix formulated which contains coefficients, then X is the one which contains variables, and strictly this one is a column matrix, then this one is the one which has constants, and also it is also a column matrix. Alright, so this is what we have. Now let's consider a case where we are given a system of linear equations. So we're going to start with the system of linear equation which has two unknown variables. So let's say we have a system of equations which is ax1 plus b we'll say let this be a1 like that. Okay, let me do it this way. Let this be as a1x then plus b1 y equal to c1. Here a1 is a constant, b1 is a constant, so the ones here just represent this coming from the first equation. The variables we have are x and y. Okay, then we have the second equation which is a2 x plus b2y equals to c2. Now looking at these two equations, they both have similar variables which are x and y, hence we can simply solve this. So here we're particularly looking at the Cramers rule, so we're going to use the same Cramers rule. So we need to find the value of x and also the value of y, which satisfies the two equations. Alright, so that is what we have. Okay, so what we're going to do is to find x, I'm going to do this. We are simply going to use subtraction like that. Now, before we use subtraction, let us try to eliminate y so that we remain with x. So we're going to try to eliminate what? Y so that we remain with x. Now what will happen is that for that to happen, the coefficients for y on both the equation we have on top and the equation we have down should simply be the same. Now for that to happen, we'll multiply first equation with the coefficient for y on the second equation, and the second equation with the coefficient for y that we have in the first equation. So we'll say that this one, let it be multiplied by b2 and this one by b1, so that these two have the same coefficients, meaning that they can be easily eliminated. Alright, so we're multiplying the first equation with b2. This one gives us a1 b2 x, then plus b1 b2 y equals to b2 c1. Then coming to the second one, we simply get a1 x, then we have here we not forgetting that we have b2 x, this is a2 here, sorry, then there plus b1 b2 y equals to b2 c2. So we now subtract. So what will happen is that for the first part here, this would be a1 b2 x minus a2 b2 x. This is equals to what we have on the other side, as this gives us a 0. So this one will be b2 c1 minus b2 c2. Right, now looking at what you have on the left hand side, x is common, so we can simply factorize x. Okay, sorry, here this is not b2, but instead it, okay, this is b2 here, then you have 1, this is b1 here instead, so meaning that here it gets to have b1. That's this one here is simply here it is b1 we have. Since we're multiplying with b1, the second equation is being multiplied by b1, and I mean that this is b1. Okay, so in this first, the left hand side, x is common, so we simply factorize our x, hence we remain with a1 b2 minus a2 b1 x equals to this side. What we have is, we can still rearrange them as c1 b2, which is fine, a minus c2 b1. Okay, so being that it is x we're looking for, so we divide both sides with what we have here, that is multiplying with x. Divide with a1 b2 minus a2 b1 over a1 b2 minus a2 b1. Okay, so what now happen is that what you have on the left cancels out. This simply goes we have x equal to c1 b2 minus c2 b1 over a1 b2 minus a2 b1. Like that. Okay, now what happens next is from matrices, this here represents determinant. This here represents determinant. So what we have here, let me explain this. This here represents determinant, where these values that we have, they come from the major diagonal. These ones, they come from the minor diagonal. It's the same case as what we have done. So this therefore yields x to be equal to determinant of this one here is the first element from the first row and the first column. Then this one will be positioned here. That is, as you can see, that from the major diagonal. Then this one, the C2 comes here. Then the B1 is here. Then what we simply have is that this is, here we have A1, A2, B1, B2 like that. This is what we have. Okay, now another notation that we can use, this one will simply be a determinant which is the determinant that we get for this matrix. So this one will just be a determinant for x, like for finding the value for x. Okay, then this one is the determinant for the matrix. So this is what we get. So this is a determinant for the matrix that contains coefficients, and this one is a determinant which will be obtained by simply substituting the row, the column rather, where x values are obtained, like from here, this one here. So this one here will be substituted with these values, hence that's the determinant we're obtaining here. So understand better when we simply look at a problem. Now similarly, if we are to solve for y, what we're going to get is this one. We're going to get this as our result. Divided by this matrix we have done. As you can see, we've just changed the order here. We simply have substituted with the coefficients that are there for y here from this system here. We've substituted with these values here. So this is b1, then b2 there like that. So that's how we obtain y, which can also be used. Well, we can also use these notations like this. Alright, so that's how we go about it, and this is how you simply find the unknown values for x and y. So the bigger the system of equations, the bigger the dimension that we'll deal with in terms of the determinant. So both the one on top and the one down should not yield a singular matrix. Thus the determinant is not supposed to be a 0. So let's look at an example. An example which backs up the information we've looked at. So we're saying solve the following system of equations, using Cramers Rule. So we have an equation 2x minus 7y equal to 4. Then the second equation is 3x plus 5y is equal to 2. So let's look at the solution. Now the first thing that we need to do is to find the determinant for this coefficient matrix. So what it is at here, let's express this system of equations in this form. In this form that we have here, where the first matrix will be a matrix that contains coefficients, then variables and constants on the other side. So let's look at the coefficients that we have. So we'll have 2, then this is 3, then there we have a negative 7, positive 5, like that. Then the second one is where we have two variables which are x and y. This is equal to, we have a 4 on top and a 2 down. Then you have something like this. So the first thing that we need to do is to find the determinant this one for this one, which we just let to be d, like that. So we need to find this one, which we just do this one. So I did this one, like that. So from finding the determinant, this major diagonal, we multiply its elements, then minus 3 divided by negative 7, which gives us 2 times 5, that is 10, negative and negative gives us positive, 3 times 7 there simply gives us, 3 times 7 gives us a 21, then 10 plus 21 yields 31. Alright, so this is the determinant. Now solving for x, what we're going to do is that here, these coefficients that we have, as these are coefficients for the x variable, we'll substitute with these constants that we have on the other side. Okay, so say 4, 2 here, negative 7, 5 to be maintained there. Then now, let's find the determinant for x. This one gives us 4 by 5 minus 2 by negative 7. 4 times 5 simply gives us a 20, negative is a positive. 2 times 7 yields 14. Adding the 2 simply gives us 34. Hence, x is equal to this determinant over the determinant for the entire system, which gives us 34. Sorry, this is just like this, which gives us 34 divided by this matrix determinant, which is 81, and this is our answer in fraction form, which satisfies the value of x in case, where we are looking at these two equations. Then now we solve for y. So what we do is the values that we have here, these elements to be maintained. Then we'll look at the right hand side. We now substitute these where we have elements that are attached to the y variable for the two equations that we have. So we have 4 and 2. So what we now do is we find the determinant. We cross multiply. We have 2 times 2 minus 4 times 3. This gives us 2 times 2 is 4 minus 4 times 3, that gives us a 12. Then now this one gives us negative 8. Hence y gives us something like this. Determinant for y is negative 8 over 13. So the two values, the one for x is this one and that one, and we are done. So that's how you go about it. And thank you very much for watching this video. Please consider subscribing to our YouTube channel, following our TikTok if you're on TikTok, and also following our Facebook page. See you in the next video.